So let's continue looking at the answer key here. I'm going to look at question number 5, where we're asked to draw some Newman projections for the indicated structures. So remember, with a Newman projection, you're basically just going to be looking down. Let me zoom in here a little bit. You're just going to be basically looking down the axis of two of the bonds. So we can go and look at our green and our orange carbons here. Now remember, you're looking from one end, right? You are looking down, and so you see the green carbon in the front, right? And the orange carbon is eclipsed behind it, right? There, you're looking down a straight line, 180 degrees. So all you see is the green carbon in the front. So we have to pick, what is coming off of that green carbon. And for the most part, we're going to see, three things coming off of these carbons. And what we have to do is pick, what's going to the left, to the right, up or down. And so what I like to do is I like to see what's in the plane of the paper, right? And if you look, that blue ethyl group there, right? That blue ethyl group is not wedged or dashed. It's in the plane of the paper. And so that's kind of the easiest place to start, what's going up or what's going down. So we can put that ethyl group right here, right? You can see that that's going down. Now the hydrogen in this case is going to be going up and to the left. Bromine here is going up. Whoops. Let me change my, there it is. Up and to the right. So the hardest part is always the first one. They're looking at the first carbon. Once you set the first carbon, then you can just see what's behind it. Again, right, if the ethyl group is going down here, it's in the plane. Up here in the back is that methyl group. Okay? So find what's on the opposite side of that ethyl group, the methyl group there. The hydrogen here was dashed, and it's off to the left. That means whatever is dashed here has to be off to the left also. So we got our carboxylic acid off to the left. Bromine was wedged into the right. Our alcohol is wedged into the right. Got it? So once you find the directionality of one of the wedges or the dashes, right, you can just do the same thing for the rest of that molecule. All right, let's take a look at this one over here. And we got our our pink carbon there that we're looking at. So we draw our circle. We see here, now our methyl group is up, right? Our methyl group is up in this case. So we start drawing our peace sign, right, with our methyl group up like that. Our hydrogen here is going to be to the left. And our OH here, let's do green. Our OH here is going to be off to the left. Okay? So hydrogen down there to the right, alcohol to the left. Now that we've established that, we can go look in the back. If our methyl group was up, right, our hydrogen in the back has to be down. Right, I'm looking at that guy right there, right, that guy right there. Okay. If our orange hydrogen was dashed and to the right, that means our methyl group here is dashed and it's to the right. And our OCH3 group is wedged into the left. So OCH3. Okay. That guy there. Okay, so the trick to these is just you have to find your perspective, look at it, and maintain that perspective through the analysis of the Newman projection.